This
mutual
conference will
exclusive
now
and
be recorded.
mutual exclusive and whatever what other thing we discussed. Hmm? Mutually exclusive and non-mutual exclusive we seen in additional rule, right? Okay. In the meanwhile, we have the multiplication rule. So you may have the multiplication rule. What is multiplication rule? So what is mean that multiplication rule? Tell me, what is multiplication rule? So product. So let me talk about multiplication rule. So when you are coming to the multiplication rule, here we have to understanding the two type of events. One is the independent events, independent event, and the second one is the dependent event. Okay, so let me go with understanding the independent event. So when you go with understanding the independent event, so for example, we can take this some example. The example is here. Here we can take some example over here. So tossing a coin. Let me consider tossing the coin. So when you toss the coin, you might be getting the head or you might be getting the tail, right? So please mute your systems. Nagalakshmi. Yeah. So when you're tossing the coin, so independently either either head, either tail, right? It is not depending on the tail, right? First maybe tail missed, first maybe head. There is no dependency, right? Okay. It can be anything, right? From this particular sample space, you might be getting only one event. So here, each and every event is identical. Okay. And each and every event or independent event is independent. Okay, it can be the tail, it can be the head. So that is what this kind of operations or this kind of events or this kind of experiment we are calling it, say, independent events. When go with the dependent variable, when you go with the dependent variable, for example, sorry, dependent event, dependent event. When you go with the dependent event, let me consider you have some bag. Okay, let me consider you have a bag. The bag, it might having the 10 balls. Out of the 10 balls, 6 balls are the red balls. Okay, 6 balls are the red balls. Rest of the 4 balls are the, for example, green. Let me consider orange. So red. Okay, white. Let me consider white. White balls. 4 balls are the white balls. Okay, 4 balls are the white balls and 6 balls are the red balls. So a bag contains the, okay, bag contains the some number of balls. Here the sample space over here, it is the 10, total 10 balls we have it, right? So by the time what you will do, first we did one particular operation. Okay, first we did a particular operation. The operation is the probability of the, okay, the probability of the picking the red ball, picking the red ball. When you are picking the red ball, so how many red balls we have it, guys? Total 6 balls, right? By 10. So this is my probability of the red balls. Okay, in my bag I have the totally 10 balls are there. Out of that one of, okay, so orange balls, but can be considered my for my satisfaction, it's a red balls. Okay, so there are there are 6 red balls are there and 4 white balls are there. So I just want to pick. Pick means what? Removing. I want to remove one ball which could be the red. When you're trying to remove the red ball from this particular bag, there might be a chance of the probability to getting the red ball, which is the 6 by 10 probability. Okay, so you are picking the red ball now. After you picking the red ball, I want to pick the white ball. The second operation is I want to pick the red ball. So tell me, so this is the operation. This is the probability which is depending on the previous event or not. Previously I picked the red ball. Okay, after you picking the red ball, you're trying to picking the white ball. Okay, so by the time of picking the white ball, so we already remove one ball. Then what will be the probability? How many number of balls we have it in this particular bag? After you removing the red ball, okay, after removing the red ball out of the 6, you may have the only 4 red balls are there. Sorry, 5 red balls are there, and four white balls are there. So totally now it's a 9. Now tell me, what is the probability of the white ball picking? It's a 4 by 9, right?
4 by 9.
Yes or no? It's a 4 by 9. See, the second probability, which is depending on the previous event. So this kind of operations we are calling it same. This kind of probability we are calling it say dependent event. Okay, so this is the dependent events. In our further classes, we'll see in a Navi base. Okay, Navi base, and you can call it's a conditional events or conditional probability. Conditional probability. So we will like to go for understanding in a conditional probability. So here the condition is we are picking one red ball. Okay, that is a conditional probability is there. So you can call it the conditional probability or dependent variables. Clear? Clear? Is it clear or not?
Yes, sir.
So that's fine. Now if I go with the independent events, when you're applying the multiplications rule for independent events, when you're applying the multiplication rule for the at what situation you are applying the multiplication rule? When we have the probability of the one event and probability of the event 2, so you are we are doing the 2 events, event 1 and event 2. You should consider the both. If the both are independent, event 1 and event 2 are the independent, then so the probability of the event 1 and with probability of the event 2, which is equal to probability of the event 1 into multiplication of the probability of the event 2. If the both are identical, if the both are independent, then this is the multiplication rule. Okay, this is the multiplication rule when it is the independent. If in case if the probability of the dependent variables, so if we have one event, the event which is depending on the event 2 or event 2 which is depending on the event 1, but I would like to go for find out the probability of the event 1 and the probability of the event 2. By the time the formula for this one, event 1, it can be multiplied with of the conditional probability conditional probability of the event 2 by the event 1. Okay. Conditional probability of the event 2 by the event 1. Okay, so this is the term we are calling it say conditional probability. Conditional probability, and this is the thing we are using in our Bayes theorems. Clear? Is it clear or not?
Yes, sir.
So we'll take some previous example only. We have the 10 balls are there. Out of that, 6 red balls and 4 are the white balls. So my first event one is the picking the red ball. Okay, picking the red ball. So probability of the R, it could be 6 by 10. After you picking the red ball, then I would like to go for picking the white ball. If you'd like to go for picking the white ball, okay, so you already picking the red ball, right? So this is nothing but probability of the second event, which is the green, probability of the event by probability of the white by red. Okay, so which means after you are removing the one ball, then what is the probability over here? It's a 4 by what it is? It's a 4 by, after removing the one, then how many number of white balls are there? It's at
4
9
by
only.
9.
Total number of balls, it's at 9 only. So you should go for apply the probability of the R and operator R by white. So this particular situation, probability of the red into probability of the white by R. So probability of the red will be the 6 by 10, and what will be the probability of the white after you picking the red? It's a 4 by 9. Okay, so whatever the value you got it, that will be our 24 or not 11. Okay, fine, 24 by 90. So this is the dependent variable. When we have the two dependent events are there, then if you want to find out the probability for AND operator of the both events, which is not possible directly, so you have to go for apply the conditional probability, which is depending, so that it should probably go for the conditional probability. Is it clear? Is it clear, or
Yes,
any
sir.
other question is there?
Yes, sir.
Okay, so so fine. When you're talking about probabilities after the, so the probability is looking something like this, and you can go ahead, if you're still interested in probability, you will go with a lot of books also, but I think so the basic level of probability is enough. You don't need to go with much in depth. Okay, so now let me go for understanding the permutations. Permutations in the sense, what is mean that permutations?
Possibilities.
Yes, absolutely correct. What are the possible combinations? Permutations. So I think permutations as well as combinations also we see in our childhood itself. Okay, when you are talking about the permutations, this is nothing but all possible options. Okay, just simple thing is that permutation is nothing but all possible options. So coming to this particular combination in the sense unique possible options, unique possible options. Okay, or you can say that unique combinations, unique combinations. This is the small difference, guys. Okay, so for example, you have the n number of samples. My sample size is n. Okay, and I would like to choose the some possible number of permutations are r. Okay, so here r and n. R is nothing but it's your so your value. So this is the npr, so you would like to go for apply the npr. Okay, so the formula for the npr, it's n factorial by the n minus r factorial, n minus r factorial. So factorial means you already know it. So factorial means n into n minus 1 into, okay, and n minus 2 into, and so on till 1. Okay, so this is what n factorial. So in the meanwhile, n minus r factorial also, it's the same thing, but it's a number only. So this npr will give you the all possible options, all possible option. When coming to the combination, you can representing that ncr. The ncr is nothing but it's n factorial by the all possible unique options, n factorial by the r factorial into, okay, n minus r factorial. So this is the small function, or this is a small formula for the combinations, guys. This permutations and combinations, you just try to understood the formulas, that's enough. You don't need to go with much information regarding about this one. Okay, like so you can go with a small aptitude book. The probability probability chapter is there in the RS Agarwal, and there we will give you, there they will there are a lot of examples also there. You just try it, you just practice it, that's it. Okay, but if you have the formula, if you have an idea of the formula, that's fair enough. Okay, it's clear, right?
Yes, certainly.
Okay, yeah. So if and only if you know the, if you know this particular probability and these things, then only we can able to go for understanding the some kind of inferential statistics. When you're talking about inferential statistics, we would like to take the conclusions, right? We would like to take the conclusions or not. By the time of conclusions, by the time of conclusions, so most of the time we need to know about some technical terms. The technical terms are, the technical terms are, it's a confidential intervals, ci means what? It's a confidential intervals. Second one is hypothesis testing. Okay, and significant value, significance value. In the meanwhile, we need to go for understanding the p value also. Okay, so confidence interval, hypothesis, significant value, p value. This is the things will give the clarity of to take the conclusions. Whether I should able to access or not, we can take some kind of conclusions. Is it clear? Is it
Yes.
clear or not? See, this is the significance value. We'll talk about the significance value. Okay, first let's talk about the hypothesis. See, hypothesis in the sense, so this is the test we will use in different scenarios. We will use in different scenarios. Okay, whether my model is fit or not. Okay, when you comparing the two samples or population sample. Okay, so if you want to compare the two groups, so different scenarios, the hypothesis testing will help you. So from this particular hypothesis testing, we have the two hypothesis types are there. One is the null hypo. One is what? Null hypo. The null hypo we can representing with H0. Okay, and so second one is alternate hypo. Alternate hypo. Hypothesis hypo in the sense that you can representing with H1. So this both are the quite opposite. So if H1 accepted means H0 accepted means H1 is rejected. If H0 rejected means H1 is accepted. That is the difference between the null hypo and alternate hypo. Okay, there are lot many possible outcomes you might be getting. Okay, sometimes you just try to understand, guys. There is a two things we need to remember. One is in a real world, in a real world. Okay, so real world scenario or else real world um, real world checking, you can say that is the real world checking or else the real world scenario. And the next one is your test, your statistical test. This is the real world test. Okay, this is statistical test. So sometimes H0 can be true, that means correct. H0 can be false. Okay, but this is sometimes in a real world H0 is true, but we might be getting the statistical test also true, but there might be a chance statistical test is failed, right? In the meanwhile, H0 is a false basically, but unfortunately we are got the result is one is the true. I mean, real world test is false, but I got the result is true. But when I go with the Real world test is a false, but I can get the false only. Okay, so real test and statistical test both are false. See, in this particular situation, so statistical test and real test, if both are true, then this is correct. And real world test and the statistical test both are true, and this is also true. That means this is correct only. But when real world test is true, but I got the statistical test is F, that means false. That particular situation, what happens? Hmm? Tell me. So this is the thing, we can call it error. Is it error or not? This is correct.
Yes, sir.
And this is also correct only. But when coming to this one, actually real test is false, but I got the result is true. That means this is also error only, right? Okay, there is a 4 possible outcomes you might be getting. One is the 2 are the correct, 2 are the false. This is the error we are calling it, say type 1 error. This is the error we are calling it, say type 2 error. One is the type 1 error, second one is the type 2 error. Clear? Is it clear or not?
Yes, sir.
Okay,
Yes.
cool. So actually this type 1 error and type 2 error in machine learning, we have the classification techniques are there, like whether the patient having the diabetes or not, whether the mail is spam mail or not, okay, whether the stocks are increase or not. That kind of scenario we are calling it a classification. By the time of classification, we have the confusion matrix is there. So from the confusion matrix, your prediction and your actuals, your predictions and your actuals, and there is a 4 possibilities are there. From the 4 possibilities, 2 possibilities are the truths and 2 possibilities are the failures. The 2 failures, we have the different names. It can be the type 1 error and type 2 error. Same things we will talk in a confusion matrix as well. Okay, is it clear? I hope you can try to understand. Hypothesis testing is very important. So the hypothesis testing, it can help you the model is good or bad. Okay, whether my model is accepted or not, that we will decide with help of the hypothesis only. Okay, clear?
Hypothesis we can use to compare only two or more than two also.
Sorry,
Hypothesis we can compare only two or we can compare more than two also.
2.
Okay, max is two.
So fine. Now when you're trying to apply the confidential intervals, so first of all you should try to understand what exactly the confidential intervals. For example, this is my data, this is my normal distribution data. Okay, in this particular situation, this is my mean, this is my mean, right? And so confidential intervals means you have some data, this is my population. Okay, you don't know the for example, this is, you don't know any information about population. You have the sample and you know the mean of the sample, you know the mean of the sample, you know the mean standard deviation of the sample. But by the time what we will do, we would like to go for estimate the estimate the population. If you want to estimate the population, at what range of the data is available, so at what range of the, in the sense, you would like to go for find out the upper and you would like to go for find out the lower, right? Lower bound and upper bound. So the lower bound, it could be the less than the mean, the upper bound, it could be the more than the more than the mean, right? So this is the two values we are calling it, say confidential intervals, lower comma upper. This is the two values we are calling it say confidential intervals. When we have some information about sample, you would like to go for estimate the population. By the time, what is the range of the data I could have it in a population, that we can able to conclude with the help of the confidence intervals. In the we have other stuff also we will apply in the confidence interval as well. But thing is that that's the basic scenario for estimating of some range of data. For that one, we would like to go for confidential intervals. Okay, so this confidential intervals, this particular confidence intervals, you can able to use for estimating the population. You just try to understand, guys. It's a point of estimator, the number of any status to estimate the value of the parameters. So you have some sample data. You have some sample data. With help of the sample data, you would like to go for estimate the population, right? Would like to go for estimate the population. So in a technical terms, the sample statistics, we're calling it a statistic. Statistics. With help of the statistics, we would like to go for estimating the population parameters. So parameters is nothing but the statistics on the population, that we are calling it a parameter, right? Okay. So confidential intervals which help you inferential to conclude the inferential statistics. And mainly if you have some kind of sample data for estimating the population, we would like to go for using the confidential intervals. Clear?
Yes, sir.
I hope this is a confidential intervals. This is the confidential intervals. It is little bit of easy things only, but we should have to follow some rules also. So when it is a confident intervals, so the mean of your sample plus or minus, okay, it can be Z or it can be, so we can apply some test. So here the test, I can tell you what are the tests are there. So you can apply it can be one sample test. We have these two sample test. There is some test. Okay, test result into standard deviation by the size of the sample. Size of the sample, square root of size of the sample. Okay, see guys, this is the test we will do in two ways. There is a two type of samples tests are there. One is the one tail test, one is the one tail test, and second one is the two tail test. Okay, so from the one tail test, again we have the Z test as well as we have the T test. That means one tail Z test, one tail T test, two tail Z test, and two tail Z test. Again we have the four combinations are available to estimating your population parameters. Okay, is there any question regarding about this one? Is there any question? Let me go for what is one tail. What is one tail? When I go with one tail, so we have the normal distribution data. Okay, I have some value, alpha value. This is the alpha value. This is your significant value. Okay, my significant values. So previously I told you, right, significance value, right? My significant value, for example, 0.5. This particular moment, 1 minus alpha in the sense 0.95. Okay, that means if I go with one tile, either 5% will be this side, rest of the 5%, 95% will be this side. So this is the one tile. The one tile will saying that we are considering only one side, either this one. Okay, for example, if I go with 5% will be this side, rest of the 95% will be this side. Okay, this is also one tile only. When I go with the two tile, so you have the significant value. We have the significance value. By the time of significance value, what will happening over here? Okay, so your alpha will be the 0.05, right? That means left side will be the 2.5 percentage and right side will be the 2.5 percentage. This is the two tile test.
Sure.
Okay, this is
Sure.
two tile test. It can
Sure.
be Z test, it can be T test. It can be T test or it can be Z test. Okay, it can be one tile or it can be two tile. Clear? Is it clear or not?
Yes, sir.
So there are a lot of possibilities are there, and when we should apply and what how we should apply that information we will see by tomorrow class, not in this particular class. But you can Google it. What is confidential interval? What is significance value? What is p-value? So p-value means it's a probability value. Okay, so p-value, significant value, hypothesis testing, and confidence interval. So just Google it. And meanwhile, one tail test and two tail test, jet test, t test, you can Google it. I can give you the full clarity by tomorrow class. And tomorrow I won't take the Python class. I can take the statistics class only. I can complete that information. Okay.
Okay, sir.
Yeah. Bye. Take care. See you.
Bye, sir.